Hi, today's problem comes from the very first question of the very first International Mathematical Olympiad, which took place in Romania in 1959. At first glance, this question seems easy enough, and pretty much it is. You wonder how this ever got into the competition, but that's how things go. So let's see what this question is, and let's prove it. We're asked to prove that this ratio is irreducible for all little n in the natural numbers. So the ratio is 21n plus 4 divided by 14n plus 3. We'll solve this two ways, and the first solution will essentially give us insight into the second solution. So we'll make this really quick. Let's first notice that if we have a ratio a over b and it's reducible, then so is 2a over 3b. Obviously, if this can be reduced, then in this expression, the a over b can be reduced as well. So let's assume that this ratio is reducible. And if that's the case, then 2 times this divided by 3 times this is also reducible. But this gives us 42n plus 8 divided by 42n plus 9. But since little n is just a natural number, this is an integer and so is the denominator. And these differ by 1. So two integers that differ by 1 means that they have no common divisor except 1. So in fact, this is irreducible. Okay, well, the second way we'll tackle this problem is to look at Bezout's lemma. And it says if you take two integers, x and y, that are not 0, then you can essentially find a linear combination of those numbers to give the number d, which is a common divisor between x and y. So can we write this quantity and this quantity as a linear combination to get the number 1? Well, let's see. If we take 3 times the denominator and negative 2 times the numerator, then what does that give us? Well, 42n plus 9 minus 42n minus 8. And that's just 1. So there, writing this and this as a linear combination to get the number 1 by Bezout's lemma, then this 1 is the common divisor of these two quantities. And so that makes the fraction irreducible yet again. And there you have it. In under 5 minutes, we've looked at 2 quick solutions to an IMO problem.